This video is going to explore data structures and sort of take them to a new level. We're going to be writing the data structures to disk and also reading them from disk. So you'll have both of those experiences. The first thing we have to do is create a data structure for our contact information. And here's the definition. Remember, the syntax is struct name, and then in here you've got all your internal fields. So for our contact, we're going to have name, address, city, state, zip, and phone number. Okay. And now what we need to do is, for right now, we're going to go ahead and declare one of these globally. So this is the type. Okay. The type is struct contact info. So let's go ahead and mark that as such. So this is the type, and this is the identifier. And the identifier, sometimes we technically it's called an identifier, but you mostly know it as a name. So this is the identifier. We could have said George, Susie, whatever. We can name it. It's just like any variable, we can name it whatever we want. So I named it CI, short for contact info. But the type is struct contact info. Okay, now what we want to do is go ahead and create a function that asks the user to enter in their contact information. So let's create a function called enter contact info. All right, pretty easy. So we're going to ask them for the name, to enter the name, address, city, state, zip, and phone. Now, in the past, what we've been using is scanf. And scanf, the only problem with scanf is at the first white space, it stops. You only get, if you're doing a scanf with a string, once you get to a white space, it stops adding it. So if you say printf, what is your name? Okay, and then if you say scanf, %s ci.name, and remember, CI is this structure that we've declared here, right? And to get to its name field, we say .name, right? So this actually works unless you say this works it works for Sam, but not Sam Smith. Because if you get to Sam Smith, what happens is at the white space, it stops putting stuff into CI name. If you just type in Sam, CI name has Sam. But if you type in Sam Smith, it's still only going to have Sam because it stops at the white space. So what we're going to do is we're going to have an alternative now that I've been waiting to introduce for a while. It's called getS, which stands for getString. And for this, getS will get the entire string, whether it's Sam or Sam Smith or Sam Q Smith or whatever, regardless of which of those your user is entering, you're going to be absolutely fine. Now we need to have the user enter in the address. Oops. Sorry about that. Address. Back that up a little bit. Okay. City, state, zip, and phone. I'm going to paste all this in. So essentially what I have here is, for each field in the data structure, just like with before when we were using scanf, we have a printf that asks the user, what's your name, lets them type it in, what's your address, lets them type it in, what's your city, lets them type it in, what's your state, lets them type it in, so forth. Notice it's this globally declared data structure dot whatever the field name is. Whatever the field name is, right? Address, city, state, zip phone. And remember, character arrays are implicitly addresses, which is why we don't have to put an ampersand in front of that, okay? Okay, so let's review that whole process. So the first thing you want to do is define a data structure. And we have this shell that goes around it. Struct is the keyword, then the name of the struct, contact info in this case. We have an open curly, and then later on a closed curly with a semicolon. Inside of here, you're going to add all the fields of the data structure. So here we have the name field, the address field, city, state, zip field, and the phone field. So this is a data structure definition, and we're going to use this for our program. Then we have to actually declare a data structure. That's different than defining it, right? Defining it is just saying what it is, kind of like laying out a template. Declaring it is the same as when you say int I or double some value or whatever. So we do this the same in C as we do any other kind of type. So first we have to put the type down. We have to say what type we're declaring. And in most of this course we've used like ints, types of int, double, float, whatever. But now we're going to use a type of the data structure that we just defined. So struct contact info, that's the type, okay? Then we need the identifier or the name. And CI is the actual identifier or name. Okay, so the type is struct contact info. That's the same as if you declare an int or a double. CI is the name. So in this program, we're going to use this data structure. We're going to ask the user for input, and we're going to allow that to go into the data structure. Okay, so we use the same pattern for each field that we're going to have the user input. And just remember that in programming, almost everything is some sort of pattern. We're going to use a pair of printf and getS. And getS just asks the user to type in some sort of string, and the string is going to be some sort of maybe a name or address or whatever. The difference between getS and scanf is scanf, if we're doing a scanf for a string, it stops at a white space. But getS will allow us to type in the whole string. Okay, here's an example. Printf, what is your name? GetS ci.name. Ci is the declared data structure. Name is one of its internal fields. So altogether, we can create a function called enter contact information, or excuse me, enter contact info. And we use this pair for each thing we want them to enter. Was your city, was your state, was your zip, was your phone. And that's all there is to it. Okay, so now that the user has actually entered in their information, we actually didn't call that for main. Let's go ahead and put that in here. So it actually happens. But now that they've entered in their contact information, we want to display it to them. Okay, so void display next record. And I know that probably should say display contact info, but later on we're going to reuse this for something else, and so it will become a more appropriate name. So all we have to do is a printf for each one of the data structure internal fields. Okay, so printf for each field, so forth. And here we'll just say display next record. If we go ahead and run this, it's pretty simple. Quasi auto 1, 2, 3 Notra. Hereville, their state. Okay. So unfortunately, we forgot our \ns. So let's go ahead and add those now. Now at a certain point we're gonna remove those. When we read this off of disk, it will already have the \ns. But for right now, we need the \ns. Okay. Now part of the problem is this only lets you type in one record. And that's really nice, but that's not very useful for anything. In addition, here we're entering the contact information, we're displaying a record. What we really want to do now is sort of add something to our arsenal and save, instead of displaying the record. Let me get rid of these because we're going to eventually get rid of them anyway. Okay, what we want to do now is we want to save the contact info. And what we're going to do is save the contact info to disk. Okay, I know up until now we've been reading stuff from disk, but now we're going to go ahead and save to disk. So let's create a function, void save contact info. Okay, and we still need our file pointer, and this is going to be different. FP, we're still going to use fopen. Right, this is going to follow the same pattern. We're going to have a file name, maybe with a path, and we're going to have an access type. The access type is going to be A. And what A is going to do is A is going to open it for appending. If it's not there, it'll get created. If it is there, it'll just write to the very end of the file. Okay, and I have actually a special path I'm going to put it into. And just make sure I don't have any conflicts with other things. Okay, so we've already talked about the double backslashes. Now you still need to arrow trap. So if for whatever reason FP is null, that means something went awry. So we'll say the contact information file could not be opened for appending. And we'll just return out of here. Okay. Now we're gonna sort of reverse the tables. We have to actually now write. We've been reading with fscanf. Now we're gonna write, but we're gonna write with a command called fprintf. Okay, f meaning file, printf. You already know how to use printf, but this is printing for a file. And the only difference is you put the file pointer first. So the file pointer is your first argument, and then you have the same kind of formatting string, and then you have the same kind of things that go in. So %s corresponds to ci.name. This %s corresponds to CI address. This %s corresponds to CI city. This %s corresponds to ci.state, and so forth. And also what I'm going to do is I'm going to put a \n in there so that each one of these will be on their same line they'll each have their own line when we go ahead and write this. We'll go ahead and do an F close. If you don't do an F close, bad things happen. Okay. So now we have enter contact information, save contact info, and let's go ahead and run this and just make sure everything's working correctly. Okay. Quasimodo. 1, 2, 3, Notre Dame. Rain. Hereville. Any state. Okay, now what do is open that folder, put a simple file name, and that would write to the current directory. Writing a record, you're going to use the fprintf function. Actually, there are lots of other functions to write a record to disk, but this is the one I've chosen because it's more in line with the things we've been doing in class. So fprintf, fp is the first argument, the file pointer. And then you have the formatting string, just like you did in printf. Remember, printf had, say, text and maybe %d, %s, %f, whatever. And then you have your arguments or parameters after that. Okay? So now we're going to write 6 strings, okay, because that's how many fields we have in the data structure. So %s, 6 times, 1 for each of the data fields. And then I have data 1, data 2, just to show you that somewhere along the way we've got to resolve that. But now I'm going to put a \n in each one of them so that each one will have its own line. So if I say the first string \n, second string \n, third string \n, that means it'll write a string and then put that \n so each one will be on its own line. And finally, what I have to do is just fill in the data structure fields so fprintf knows where to get the data from. Okay. You always have to remember to close the file. So here it is all together. Here's the function, save contact info. We declare fp, we open the file. We have to error trap it just in case something went wrong. We call fprintf, and finally we close the file. Now, a lot of times you're going to want to let the user add multiple contacts before they quit. This only allows you to do one. It enters the contact and then saves it. We want to go ahead and put this to where the user can continue to add contacts as long as they want to. So the best control structure for this is a do while. And I'm going to suggest that what we do here, after they've entered one in, we ask them if they want to do any more or if they want to quit. You can do this actually quite a few different ways, but this is the way I'm going to do it for right now. If you want to down the road change this, that's fine. So printf, any more records, quit, or yes. Okay, so we're going to ask them that. Yes, we could use actually a scanf, but we'll use getf since we've been using that just to be consistent. So now we have their answer. Okay, so our while loop is going to say while SERICMP answer quit. Oops. Does not equal 0, right? So this, if it compares answer to quit, if answer is quit, this will return a 0. But we want to keep doing this while they did not type in quit. Okay? So now if I run this, it should let me enter more than one record. Okay? Sam Hill, 444 Main Street, Orlando, Florida, 32323. Okay. Oops. It's a funny zip code. Oh well, that's fine. So now if I type in quit, it will stop, but if I type in yes, or really anything else, it will ask me for more records. Susie, Hill, let's say Dale, Elm Street, Oviedo, Florida, 32323. Okay, so now it let me enter in 2 records. And I'm going to go ahead and say quit because that was all I wanted to enter in. And now since I entered in quit, it stops, okay? Okay, so we really want to let the user enter more than 1 record at a time. Or actually 1 at a time, but they can continue to add records if they want to. So here I've got a little map in plain text, not computer code. Well, do while is sort of computer code. So we're going to do this while their answer is not quit. So the user will enter a record. The record will get saved to disk, and then we're going to ask them if they want to enter more records, yes or quit. Okay, and these next few slides, I'm going to go ahead and show you how we replace all the English text here with actual computer text. So first, all we do is we say enter contact info, that function, right? We had the English text, and then we replaced it with a function. Now we're going to replace save record to disk with a function. Ask if they want to enter more records is actually 2 steps. It's a printf saying more records, a yes or quit, and then we'll do a get s so they can type it in. Okay, so that'll actually, it won't be a single computer line, it'll be actually 2. First though, we have to go ahead and declare an answer, a char buffer for answer. And then we say printf, more records, quit or yes. We let them type it in. And the last thing we have to replace is this while their answer is not quit. And we're going to use stricmp to compare answer with quit. Okay, stricmp, we're going to compare answer and quit. If these are the same, it's going to be 0. If it's 0, we want to bail out. But if it's not 0, we want to keep doing more. Okay, and that's all there is to it. Okay, so what we're going to do now is take a look at the contexts that have been entered in. And this is kind of a temporary thing. We're eventually going to get rid of this, but for right now, let's create a function called display contacts. And this will actually display all contacts on the disk. Okay, and so first thing we'll do is we'll create that function. And we need a file pointer because we're going to open a file. And we do need a temporary char buffer so we can read in each line. We're going to attempt to open up the file. And this time we're going to try to open it up for reading. We're not going to be appending anything, so what we're going to do is just go ahead and read this in. We've got 3 and not 2. That's from yesterday. Now what's really interesting is there's a command called feof, so let's make sure we do our close here. What feof means, while file not end of file. And essentially feof looks to see if you're at the end of the file. While it's not the end of the file, we're going to read in a record and display a record. Okay, pretty simple. Read the next record and display the next record. So now we have to create the read next record function. Okay, and that's essentially a very simple thing. All it does is it reads each database field, each data structure field using fgets. Now one thing is important. each line will end with backslash. So later on that's going to be important, but each line, when you read it from disk, will have a backslash in. Okay, so here we've read in a record, so now this CI thing that we declared a long time ago is going to be populated. Now we need a display next record function. Okay, so here's display next record, and all we're doing is a printf. Notice that we don't have a backslash n here, and here, and here, and so forth. The reason is because these fields all already contain a backslash n. Okay, and the reason for that is that fgets, when it reads from disk, it reads the whole line and will also read the backslash n. Okay, so now let's go ahead and run this guy and make sure it works okay. Oh, I already have display next record somewhere, so let me get rid of this so everybody's happy. Okay. Here's your name, Rick Lineker, 410 Forest Island Drive, Orlando. I misspelled Orlando. Oh well. I'm going to quit. And once I quit, it's going to show me everything in the contact database. Okay? All right. So we actually just did a good bit of work. Let me kind of go back and make sure it's clear. First, I called this display contacts function here. In display contacts, open the disk file. Here, close the disk file for good housekeeping. And while I'm not at the end of the disk file, it reads a record and displays a record. Okay? Now, reading the record is simple. For each record, each field in the data structure, it reads in a line, reads in a line, reads in a line, reads in a line, so forth. And to display that is simple. All it does is use a bunch of printfs. Okay, so for each field in the database, it does a printf. Okay, so what we're going to do is create a function called display contacts, and we're going to do that toward the end of main, right before the return 0, so that we can go ahead and display all the contacts that we have in the disk file. So first, we're going to add the functionality to the display contacts function. There's the body of the display contacts function. First, we have to declare a file pointer and a temporary char to read in each line. And then we're going to go ahead and attempt to open the file. Notice we open the file for text reading with the R specification. We have to error trap it, make sure it opens up. Remember to close it before we leave this function. While we don't get to the end of the file, FEOF means, are we at the end of the file? While we're not at the end of the file, read the next record and then display the next record. Notice for read next record, we pass it in as a function parameter, the file pointer. Okay? Okay, so creating the function to read the record, we simply use 6 fgetS calls. Please bear in mind that when you use the fgetS call, it's going to read in the \n. So each one of these strings or character arrays is going to have a \n at the end of it. Now the function to display the next record, we just use printfs, 6 printfs, and that's really all there is to it. So the last thing we're going to do in this exercise is to go ahead and ask the user for a name to search for, and then search for it in the contacts. And if we find it, we'll go ahead and display it. If not, We won't. So what I'm going to do is I'm going to get rid of all of this. And all that code, by the way, is in the web course. I've uploaded it all. So here we're just going to say printf, enter the name for which you want to search. Obviously we have to have something after that, so we're going to use a getS answer, right? Don't forget answer is declared here and used here. Okay. Now what we're going to do is we're going to create a function called doSearch, and we're going to pass it in answer as the parameter. Okay. We could actually put all of the code, instead of calling doSearch, we could have put all the search code right here, but what that would be, it'd be a lot of code. And we have this idea in computer science called separation of concerns. So we want to keep things clean. Let's say doSearch, char, I'm going to say search criteria. Please notice, and we covered this quite a while back, these can have different names. This is passed in here, and this is going to be local to the doSearch. So it's legal to have those have different names. The next thing we need to do is open a disk file, right, because it is a disk file. We need to read through it. So we can copy that in. That should be 3. Okay, so we just need to open up the file. Oops. Make sure it actually opens up. Air trap it right here, right? Okay. And I'm going to go ahead and put my F close down here like I like to do, just to make sure I remember to close it at the end. Okay. Now, this is the process. Read each record compare search criteria to the record display if matched. Simple, right? We read through it. Once we find a match, we'll go ahead and display. So this is a trick we've already learned. While not FEOF, right? We're going to keep reading through this. Put this at the end here. And let's go ahead and indent those so everybody's happy. Read next record. Now notice that I'm reusing this function. This is one of the goals of programming functions, is that I can reuse them. I used that before in code that I had written. Now I get to use it again. So since it's a properly written function, I can reuse it anytime I need to read a new record. Okay, so that's read each record. The next thing, if str ICMP search search criteria ci.name equals 0. We'll say display next record. Okay. Now put this up here. It's coming up here. That's all there is to it. Now there is one complication though that we're going to have to deal with. This is fairly straightforward, right? stricmp, the search criteria, and the name. The problem with this code is that name has a \n appended to it, or I'll say at the end. So what that means is that it will never find a match because our search criteria is never going to have a backslash n. So what I'm going to do is I'm going to concatenate a backslash n. There are two ways to do it. Actually, I'm going to show you both ways. Method 1. Concatenate backslash n to search criteria. And that way, they're both going to have a backslash n, right? So now you're going to find a match. So that's one way. That's the easiest way. Method 2, use the length of search criteria for the comparison. So here, if we're going to use this method, we need a length variable. Len equals string length of search criteria. And if I'm going to use method 2, method 1, let me put in method 2 here. For method 2, it would be an n, meaning I'm going to give you how many, and it will be length. Okay, so that way it would only go ahead and compare that. I'm going to suggest, though, that for simplicity we stay with method 1. I showed you method 2 in class, but I think it's probably a little bit better to just go ahead and use method 1 for simplicity. Okay, and that's all there is.